Okay, so there's our k value, and if we do round to the nearest fourth, it would be 0.2197. Tens, hundreds, thousands, 10,000s, I guess is what we rounded to. All right, so either one is going to give us a pretty accurate answer. Let's go on to step 2 and figure out what the question is asking. Estimate the time required for the population to quadruple in size. Okay, so the initial population is 100. So if we want it to quadruple in size, our n value is now 400. So I am replacing the n with the quadrupled size of 400. And for the k, remember, we know that this is going to be 0.2197. I'm going to go ahead and use what I wrote in green just because it's a little bit more accurate of an answer. And then don't forget, we do not know the hours now, so the letter T is going to stay there. All right, let's go ahead and divide both sides by 100 to get this e by itself. So 4 equals e to this exponent right here. Let's go ahead and convert this to log form. So when we convert this to log form, remember it is going to be natural log of 4. And it always equals the exponent. So 0.2197t is going to be over here on the right side. Let's go ahead and get t by itself. So t is going to equal ln of 4 divided by the 0.2127. I'm sorry, 0.2197. So let's go ahead and solve this on our calculator. So we're going to take the natural log of 4. And then don't forget we're dividing by 0.2197. So it's going to take approximately 6.31 hours. So time will be 6.31 hours. Okay, let's see what's going on with number 3. The number of hits of a new search engine website receives each month is modeled by this function, and my fold cut off the exponent. So the exponent is to the kt. Sorry about that. All right, so we know that t represents the number of months this time. And the website's in its 3rd month. They had 10,000 hits. We need to find the value of k. Guys, k is usually understood for a constant. So that's going to be a value that does not change like the t does as time progresses. So let's go ahead and figure out k. Then we'll go ahead and figure out how many hits after 24 months. So back to the beginning of the problem. We know that in its 3rd month there were 10,000 hits. So we are going to have 10,000 over here on the left side. I'm going to recopy the 4,080. And remember, this is e to the 3k. We're determining the constant. This is step 1 of this process. So let's go ahead and divide both sides by 480. Now again, I can show you this one more time. I'm going to hit clear. So 10,000 divided by 4,080 is going to give me this decimal, but I prefer a fraction. I'm going to hit the second PRB key. And again, what this is telling me, there's 2 whole numbers out there. Now remember, a whole number in terms of 51 is 51 over 51. So my numerator as an improper fraction is going to be 23 plus 2 of those 51s. So my numerator is going to be 125 over my existing denominator of 51. And that is going to equal e to the 3k. Let's go ahead and put this in log form. So natural log of 125 over 51 is going to equal 3k. So let's divide by 3, and then we'll have our k value. So k is going to equal the natural log of 125 over 51. Remember, all of this is being divided by 3. All right, here we go. Natural log of 125 divided by 51. And guys, don't forget to hit divide by 3. So there's our constant. Let's say that it's approximately 0.3, but let's go ahead and round. So I'm just going to say it's 0. I know I'm going a little farther than what I usually suggest, but again, I do want a pretty accurate answer, so I'm carrying it out just a little further. We'll just make that a 3. All right, so now that I have this constant, now I'm really able to answer the main question, which is going to be the prediction of number of hits after 24 months. So this time I don't know the total number of hits. So where that 10,000 was, we're going to just keep plain old y there. So y equals 4080, and that's going to be e to the k value, 0.29883. And remember, this time we don't know how many hits, but we do know it's going to be 24 months. So let's put 24 right here. So now, if you notice, I don't have any variable, guys. This is just order of operations. There's no variable over here. So we're just going to go ahead and plug this in. So it's going to be 4080 times e. And remember, e has an exponent of 0.29883 times 24. I kind of went overkill on that decimal, but that's okay. Guys, at the end of this, if you are deciding to do this all in one step like I am doing, please make sure you have double parentheses at the end and hit enter. And then there we go. As you can see, it looks like we're going to have a lot. That's on 5.3 billion. Let's go ahead and say the number of hits is going to be 5,313,558 hits. Okay, that's going to be problem 3. Let's see what's going to go ahead and happen with problem 4. So for problem 4, guys, we're going to start looking at half-life. And half-life is up here at the top of your page. Remember, A sub L means amount left. A sub O means initial amount. There's your half. T is time, and K is some constant. And sometimes we have to find the constant, sometimes we don't. Let's go ahead and read the problem. Okay. So 210 years ago, there were 132,000 grams of cesium-137. How much is there today? And the half-life of cesium is 30 years. Okay, that's great. So I know that this is the K value. So I'm not really solving for that yet. So let's plug in what we know. We know that there was this amount. The was part was the A sub O, or the A sub 0. So amount left is going to equal the beginning amount of 132,000 times the half base. And remember, the K was 30,000 or 30 years, but the T goes on top. And if you remember, it says here there was 210 years ago. So this is going to be 210 divided by 30.